Somewhere beyond the edge of everything we've named, beyond the stars we've mapped and the galaxies we've catalogued, something waits. It does not announce itself. It does not pulse in any rhythm we recognize. It simply exists, massive, distant, uncertain. Tonight, we try to look at it, and in doing so, we ask a question that may not yet have an answer. Is it a star, or is it something the universe has kept secret from us? Until now. Hello, and welcome to Infinite Science. Take a breath with us. There is no hurry here. Where we are going, time moves differently. Distance stretches in ways that make our ordinary measurements feel almost quaint. A kilometer, a mile. These are things we invented to make sense of the world beneath our feet. Out here, out in the space between what we know and what we can only imagine, such words stop meaning much, of anything at all. You are welcome here in this quiet. You are welcome here in this darkness that is not really darkness, because even the deepest reaches of the universe are threaded through with ancient light, with the slow exhale of galaxies, with the echo of things that happened long before the Earth was even a thought. We built this channel, Infinite Science, because we believe that one of the most profound things a human being can do is look up. Not for answers necessarily, not always for solutions or data or proof. Sometimes simply to look, to let the enormity of things settle on the chest like a gentle weight, to feel for a moment the particular kind of smallness that is not frightening, that is, in fact, a relief. You are small, we are small. Every city, every ocean, every mountain range, every civilization that has risen and fallen on this pale blue speck of a world. All of it is small when held against the canvas of what actually exists out there. And yet, we are also the part of the universe that looks back at itself. We are the part that asks questions. We are the part that wonders. And in that wondering, in that specific, beautiful, deeply human act of curiosity, we are something remarkable. We are the universe becoming aware of its own mystery. Tonight, we want to introduce you to something. We're going to take you somewhere far from the familiar, far from the constellations you learned as a child, far from the planets with their friendly names, far from the sun that warms your face on a summer morning. We're going to take you to a place in the cosmos where our instruments have picked up something that, frankly, we are still trying to understand. Something immense, something ancient, something that does not quite fit the boxes we have built for the things we thought we knew. Its name for now, the name we have given it, because we had to call it something, is Behemoth. In the old texts, the ancient human texts, the sacred stories, the mythologies carried forward across thousands of years, a behemoth was the thing beyond comprehension. The creature so vast, so outside the ordinary logic of nature, that it could only be described as something apart, something that existed in a category of its own. The name feels appropriate. But before we go any further, before we go out to where Behemoth waits, let us sit here for just a moment longer. Let us sit in this quiet. Let us let the stars come out. Because the universe is a place of extraordinary patience. It has been unfolding for nearly 14 billion years. It will unfold for billions more. And in the middle of all that time, in this particular strange, improbable, luminous moment, you and I are here, looking up, wondering. That is enough. That has always been enough. Now, gently, slowly, with all the wonder that the dark deserves, let us begin. But before we do, one more thing, one more breath in the quiet. We want to say something about science. Not in a formal way, not in the way of a textbook preamble or an institutional disclaimer. Just as one curious mind to another, across whatever distance separates us right now. You in your room or your bed or your car or wherever you are as you watch this, and us here in the strange and beautiful business of making something from nothing but words and images and the love of questions. Science is often presented as a body of facts, a collection of settled things, a catalogue of what is known. And it is those things, it contains those things. But at its living edge, science is something much more interesting. It is a practice of honest uncertainty. It is the ongoing, never-completed project of looking at reality as carefully as possible and reporting back as truthfully as possible, and holding the resulting knowledge with the exact right combination of confidence and humility. Confident enough to act on it, humble enough to revise it when the evidence demands. This balance, this equipoise between conviction and openness, is one of the hardest things to achieve in any intellectual endeavour. And it is the thing that makes science at its best not just useful, but beautiful. There is a particular kind of beauty in saying, here is what I know, here is how I know it, and here is the edge of my knowing, the place where the light runs out and the dark begins. Behemoth lives at that edge. That is why we are here. That is why we find it extraordinary. And now, with all of that preamble offered, all of that framing settled, all of that quiet permission given to simply be curious and uncertain and alive in the wonder of not knowing, now we truly begin. Take a breath, let it out slowly, and follow us into the dark. There it is. Don't blink. Don't look away too quickly. Let your eyes adjust. Let your mind do what minds do when they encounter something they weren't prepared for. Let it slow down. Let it hesitate. Let it circle the edges of what it's seeing without immediately rushing to name or categorize or explain. That tendency, the tendency to explain immediately, is one of the most human things about us. We see something, and within seconds we are reaching for a label, a comparison, a filing cabinet in the mind where we can store this new thing alongside the things we already understand. It is how we survive. It is, arguably, how we built civilization. But sometimes, just sometimes, a thing resists that impulse. Sometimes a thing is so far outside the ordinary experience of objects in the universe that our labels don't quite stretch far enough to cover it. Behemoth is one of those things. Let us try to describe it, not define it, just describe it. The way you might describe a dream that still feels vivid but loses its sense as you reach for words. Imagine the largest thing you have ever tried to imagine. Not the largest thing you've seen, because you have never seen anything like this. Just the largest thing your mind has allowed itself to conceive. Perhaps a mountain range, seen from above. Perhaps the spread of a city at night, its lights bleeding out to the horizon. Perhaps an ocean, not a beach, not a stretch of coastline, but all of it. The whole ocean. The depth and the surface and the slow turning curvature of the earth, holding it all in place. Now multiply that. Multiply it again. Now keep going, not for minutes, not for hours, but for the kind of quiet, patient multiplication that takes you past all the borders of ordinary sense. Past the planet, past the solar system, past the distances between stars, past the dimensions of the galaxies we have named and numbered and studied for over a century. And then, somewhere out in that uncharted territory of scale where human intuition simply runs out of floor, there is Behemoth. It is large in a way that doesn't translate. That's the honest truth of it. When astronomers first flagged this object, first circled it in their data with the cautious excitement of people who know better than to get too excited too soon, The problem they immediately ran into was one of language, of framing, of how to communicate magnitude to other human beings using tools, words, comparisons, analogies, designed for a world of human-sized experience. The Sun, to give you a reference point, is about 1.4 million kilometers across. That's a distance so enormous that if you were to drive to it at highway speed, assuming you could, it would take roughly 200 years. 2 centuries of driving to cross the diameter of our star. Most stars, the ordinary ones, the quietly burning ones, fall within a range from somewhat smaller than the Sun to somewhat larger. Even the giants among them, the red supergiants that make our Sun look modest, come in at perhaps 1,000 times the Sun's diameter. Impressive, staggering really, if you sit with it. And then there is Behemoth. The numbers, when they are applied to it, become almost ceremonial, almost meaningless, not because the numbers are wrong, but because human minds were not built to hold such quantities with any real emotional comprehension. We can write the figure down, we can place it in a table, we can nod and say, yes, very large, and move on. But to feel it, to actually feel what that scale means, that is something else entirely. That is the kind of feeling that arrives in the middle of the night, sometimes when the thinking mind is quiet and the deeper, older part of you is allowed to take over, the part that knows on some wordless level that you are made of atoms that once were stars, and that you are held to a planet by forces you cannot see, and that beyond every wall and window and horizon, there is more universe than you will ever have a lifetime to comprehend. Behemoth sits in the data like a stone in still water. It is simply there. It does not care that we are looking at it. It does not respond to our instruments with anything other than the quiet, steady fact of its own existence. And that indifference, that enormous cosmic indifference, is somehow one of the most affecting things about it. The universe does not perform for us. It does not arrange itself for our benefit or our understanding. It simply is. And Behemoth, vast, strange, distant, patient, simply is. We have seen it now. We have turned our instruments toward it and made our measurements and run our analyses. And what we have are numbers that don't quite fit the boxes we built for them. Signals that don't quite match the patterns we expected. A thing that is, by every account, real and present and enormous. And deeply, quietly, persistently mysterious. We've seen something, but we don't yet understand it. That is where we begin. There is a tradition in astronomy, old, informal, almost superstitious in its persistence, of giving nicknames to objects that resist easy description. Objects that don't fit neatly into the naming, conventions of catalogues and surveys. Objects that arrive in the data like unexpected guests, occupying space that wasn't prepared for them, demanding attention before anyone is quite ready to give it. The nickname Behemoth was not a casual choice. Among the people who first flagged this object for serious follow-up observation, it was one of those names that seemed to arrive already earned. You look at the numbers, and you look at each other, and you say, we need to call it something. And someone says, almost under their breath, something that means enormous and ancient and deeply strange. And everyone nods, and the name sticks. Names matter in science more than scientists sometimes like to admit. The name you give something shapes how you think about it. A label is never merely a label. It carries assumptions, associations, implied taxonomies. By naming it Behemoth, these researchers were doing something specific. They were refusing to pre-commit to a category. They were keeping the question open by using a name that meant large, mysterious, beyond ordinary reckoning. A name that didn't claim it was a star, that didn't claim it was a galaxy or a nebula or a known type of transient. A name that said, This is a thing, and we don't know what kind of thing it is, and we need a word that honors the not knowing. It is a good name. It is a name that invites you to look carefully before you decide. We have the data. That much is certain. The measurements are real, verified by multiple independent instruments, checked and cross-checked against calibration sources, filtered for known artifacts and instrumental noise. Whatever Behemoth is, it is there. It is producing the signals we have detected. It is occupying the location we have mapped. It is real in the most fundamental sense that science uses the word. It is something that consistently shows up in the physical world when you look for it with the appropriate tools. The uncertainty is not about whether it exists. The uncertainty is about what it is. And that distinction between doubting the existence and doubting the interpretation is crucial. We are not in the territory of anomalies that turn out to be instrumental glitches, or signals that evaporate under scrutiny, or detections that prove to be artifacts of a poorly calibrated sensor. We are in the territory of something genuinely present in the universe, something real and enormous and strange. The question is not, is it there? The question is, what is it that is there? And that question, humble in its wording, staggering in its implications, is the engine that will drive everything that follows. Before we can properly understand why Behemoth unsettles us, we need to talk about stars. Not in the technical, textbook way, not in the way that lists spectral classes and luminosity ranges and the precise temperatures at which hydrogen begins to fuse. We're going to talk about stars the way they deserve to be, talked about, slowly, with the appropriate sense of reverence for what they are. A star begins in darkness, in the great cold clouds of gas and dust that drift between the galaxies, the nebulae, the interstellar medium, the places where light does not reach and temperature drops to only a few degrees above absolute zero. There are regions where gravity slowly, patiently gathers material, molecule by molecule, particle by particle. It is not a dramatic process at first. It is the quietest thing in the universe. A gentle accumulation, a slow concentration of matter in one place rather than another. But gravity is patient. And given enough time, given the kind of time that makes a human lifetime seem like a blink, the kind of time that makes civilizations seem like brief, bright sparks, enough material gathers. The cloud begins to collapse under its own weight. It heats up, it compresses, it begins to spin, slowly at first, then faster, the way a figure skater accelerates when they pull their arms in. And then, after tens or hundreds of thousands of years of this patient, invisible process, something happens at the core of all that gathered material. The temperature rises past 10 million degrees, and hydrogen atoms, stripped of their electrons, begin to collide. They begin to fuse. Two hydrogen nuclei become one helium nucleus. And in that transformation, in that fundamental act of nuclear alchemy, energy is released. The cloud lights up. A star is born. It sounds almost simple said that way. And in a sense, in the grandest possible sense, it is. It is one of the most fundamental processes in the universe, repeated across billions of galaxies, for billions of years, in all the varieties and scales that physics permits. The universe makes stars the way the ocean makes waves, continuously, inevitably, as an expression of its deepest nature. But what a star does, once it is born, what it becomes and how it lives, and how it dies, that is where the real richness lies. And that is where the universe begins to show you just how many ways it has found to do the same fundamental thing. A star is at its core a balancing act. On one side of the scale, gravity, that great inward pull, trying always to compress the star, to squeeze all that mass into a smaller and smaller volume. On the other side, the pressure generated by nuclear fusion at the core, the outward push of energy, the radiation pressure and thermal pressure that keeps the star inflated, keeps its outer layers from collapsing inward under the weight of everything above them. For most of a star's life, for the vast majority of its existence, these two forces are in balance. Gravity pulls in, fusion pushes out. The star holds its shape, it shines, it radiates. It turns hydrogen into helium slowly and steadily, and the light it produces travels outward at the fastest possible speed, the speed of light, and goes out into the universe in all directions forever. Our sun, for example, has been doing this for about 5 billion years, and it will continue for another 5 billion years or so. 10 billion years in total of steady, patient shining. That is a time span so enormous it erases the entire history of complex life on Earth dozens of times over. And yet, in the cosmic scheme, it is not particularly unusual. There are stars much older than our sun. There are stars that have been burning for nearly as long as the universe has existed. When a star's hydrogen runs low, when the fuel at the core has been converted slowly and completely into helium, things begin to change. What happens next depends enormously on the mass of the star. For a star like our sun, the changes are dramatic in geological terms, but gentle in cosmic ones. The core contracts, the outer layers expand, the star becomes a red giant, swelling outward to perhaps 100 times its current size, and then, over millions of years, sheds those outer layers into space, forming a beautiful, glowing shell of gas called a planetary nebula, while the core that remains, a dense, hot, slowly cooling ember called a white dwarf, persists for billions of years, gradually fading. For more massive stars, the endings are more violent. The core collapses with such ferocity that the outer layers rebound in a colossal explosion, a supernova, one of the most energetic events in the universe. What is left behind may be a neutron star, a dense, rapidly spinning object the size of a city but with the mass of the sun. Or, if the star was massive enough, something even stranger, a black hole. A point of such extreme gravity that even light cannot escape it. This is what we know about stars, the general shape of it, the broad sweep of the process. And it is deeply beautiful knowledge, hard-won, built up over centuries of careful observation and mathematical work, refined and tested and confirmed. We are confident in it, in the way that science allows us to be confident in things. Not with certainty, but with a very high degree of well-supported probability. And then there is Behemoth. And Behemoth looks at all of this, at these carefully constructed models, these centuries of hard-won knowledge, and it doesn't quite fit. Not in the way that suggests we've made an error. Not in the way that sends astronomers back to scratch their heads over a calculation. More in the way that a new species doesn't fit the taxonomy you had so carefully assembled. Not because the taxonomy was wrong, but because the universe, it seems, has found another way, another form, another possibility. A door half open into something we haven't named yet. Let us dwell on this for a moment longer, because the history of astronomy is, in part, a history of encounters with things that don't fit. And each time the encounter has changed us, changed what we know, changed what we are prepared to believe, changed the size and shape of the universe that we carry around in our minds. When Galileo pointed his telescope at Jupiter and observed 4 small points of light moving around it, changing position from night to night in a regular, predictable pattern, He was looking at something that shouldn't have been possible according to the model of the universe that everyone around him accepted. Moons of Jupiter? Worlds orbiting something other than the Earth? The telescope was barely a year old as a scientific instrument, and already it was showing people things that shattered their cosmology. When William Herschel discovered Uranus in 1781, and it is worth noting that he didn't set out to discover a new planet, he was conducting a systematic survey of the sky, and Uranus simply appeared, odd and slightly fuzzy among the stars. The solar system that everyone thought they knew had a new member. The edge of the known moved outward. The boundary retreated. The universe grew, suddenly, and, without warning, larger than it had been the day before. When Hubble looked at the Andromeda Nebula in the 1920s and measured the distance to the Cepheid variables within it, and found that they were unimaginably far away, far too far to be part of our own galaxy. The cosmos expanded overnight from a single galaxy to an infinite field of galaxies. The Milky Way, which had seemed to be everything, turned out to be one among hundreds of billions. One grain of sand on a beach so vast that the metaphor immediately breaks down, and you are left simply staring at the number in a kind of overwhelmed silence. Each time, something that didn't fit. Each time, a reframing of the whole picture. Each time, the universe proving to be stranger, larger, more various, more astonishing than the model that had seemed adequate the day before. Behemoth may be one of those moments, or it may not. It may turn out to be a known type of object, viewed under unusual conditions, and the strangeness will resolve into familiarity once the right piece of evidence arrives. Science allows for that. Science is comfortable with the possibility that today's mystery becomes tomorrow's textbook entry. But we don't know that yet. And in the not knowing, there is electricity. Let us talk about rules. Not in the strict legalistic sense, not laws in the way human societies make laws, which can be broken and amended and argued over in courts, but rules in the sense that nature has rules, physical laws, the deep grammar of how the universe is written. Gravity behaves in a particular way. Light travels at a particular speed. Energy is neither created nor destroyed. Matter comes in particular forms, behaves according to particular principles. These are not suggestions. They are not conventions. They are the fabric of things. The structure beneath all structure. And within those rules, stars are a known quantity. We know what they look like at various masses. We know how they radiate, and in what frequencies, and at what intensities relative to their size. We know how they move through space, how they interact gravitationally with their neighbors, how they alter the light of anything behind them. We know, in short, what a star should look like, even a very unusual star, even a star at the extreme end of the mass scale, one of the so-called hypergiant stars like R136A1 or Eta Carini, objects so massive that they strain our models almost to breaking point. Even these have properties we can catalogue, measure, place within a framework. Behemoth does not cooperate with this framework. The first thing that raises eyebrows is the mass, the sheer quantity of material apparently contained in, or associated with, Behemoth. Because even at the high end of what physics permits for a single stellar object, there are limits. Limits set by something called the Eddington luminosity, a kind of natural ceiling on how bright, and therefore how massive, a star can be before the pressure of its own radiation begins to push its outer layers away. Before it begins, essentially, to destroy itself. The universe has a sense of proportion. It sets upper limits. It builds in safeguards that prevent things from growing beyond a certain point before they must change form. A star cannot simply grow and grow without consequence. At some threshold, somewhere in the range of around 150 times the mass of our Sun, though the exact figure is still debated, a star's own luminosity tears it apart. It becomes violently unstable. It sheds mass in enormous eruptions, like a person pacing in a room that's too small for them, unable to contain the energy of their own presence. And yet, the measurements associated with Behemoth suggest something that exceeds these expectations. Not slightly, not by a margin that could be easily explained by measurement uncertainty or instrument error, but in a way that prompts the question, is this actually a star? Or is it something that merely appears from a distance to resemble one? The second thing is the signals, the light, or rather the electromagnetic radiation more broadly, that Behemoth emits. Because stars emit across a range of wavelengths, and that spectrum is like a fingerprint. Spectroscopy, the art of breaking light into its component frequencies and reading what those frequencies tell us, is one of astronomy's most powerful tools. It tells us the temperature of a star, its composition, its velocity relative to us, whether it's moving toward us or away. It is a language, and astronomers are fluent in it. Behemoth's spectrum is strange, not indecipherable, strange. Some of what it says is familiar, the way a melody is familiar even when it's being played in an unexpected key. Hydrogen is present, helium is present, but there are other signals, other absorption and emission lines that don't fit neatly into the profile of any stellar type we have on record. And the overall shape of the spectrum, the way the brightness varies across different wavelengths, has an architecture that our models struggle to reproduce. We keep building the model, we keep running the equations, and something doesn't close. Something in the accounting of energy doesn't quite balance. Too much comes out, or it comes out in the wrong frequencies, or both. The third thing, perhaps the most unsettling thing, is the behavior over time. Stars change. They vary in brightness. Some do, at least. Variable stars are a known phenomenon, studied and catalogued for centuries. But the variability follows patterns. Even the most chaotic-seeming variable stars, the ones that pulse and surge and dim, can be described by mathematical models of what is happening inside them. We can explain the rhythm, even when the rhythm is complex. Behemoth's variability, and it does vary, its apparent brightness shifting over the periods during which we have observed it, doesn't follow those patterns. It doesn't follow any pattern we've seen before. It changes in ways that are not random, exactly. There are suggestions of structure in the data, of something almost like rhythm, but not in any rhythm that corresponds to the interior oscillations of known stellar types. It is as if something is beating inside it that we have no name for. A pulse from a heart whose anatomy we have not yet mapped. What if it's not behaving like a star at all? What if we have been looking at it through the wrong lens? Not because our instruments are faulty, not because our scientists are careless, but because the category of star, the very concept, the very word, is simply not large enough to hold what Behemoth is. That is a frightening thought in the best possible way. That is the kind of thought that does not let you sleep and keeps you at the telescope long after the coffee has gone cold and makes you feel, despite everything, despite all the hard work and long years and accumulated fatigue of doing science, genuinely, achingly, wonderfully alive. Let us follow it. There is something worth saying here about the nature of anomalies. In everyday life, anomalies are often dismissed. A thing that doesn't fit is assumed to be broken or mistaken, or the result of someone not looking carefully enough. We are trained in many contexts to distrust the outlier, to sand it down into agreement with the average, to explain it away with the comfortable tools of familiarity. Science, at its best, does the opposite. In science, the anomaly is precious. The thing that doesn't fit is the most interesting thing in the room. It is the crack in the wall through which you can sometimes see an entirely different structure on the other side. The history of physics in particular is a history of anomalies taken seriously, of people who noticed that something in the data was slightly, stubbornly, persistently wrong, and who followed that wrongness patiently until it led somewhere new. The precession of Mercury's orbit was an anomaly for decades before Einstein's general relativity explained it. The orbits of outer planets nudging in ways that Newtonian mechanics couldn't fully account for. This was the anomaly that led, eventually, to the prediction of Neptune's existence before it was directly observed. The ultraviolet catastrophe, the failure of classical physics to correctly predict the spectrum of radiation from a hot object, was the anomaly that cracked classical mechanics open and allowed quantum physics to pour through. What lies on the other side of Behemoth's anomaly? We don't know. But the question itself, the shape of it, the texture of it, the particular way it resists easy resolution, is enough to keep us looking. Enough to keep the instruments running and the data flowing and the minds turning night after night in the long, patient work of trying to understand something that is not yet ready to be understood. That work is a gift. Not always a comfortable one, but a gift nonetheless. What if the category of star is simply not large enough to hold what Behemoth is? When a thing doesn't fit the established categories, science does what it has always done. It generates hypotheses. It proposes possibilities. It assembles what the data permits and then, carefully, tentatively, with the appropriate humility, it imagines. This is not guessing. It is not wild speculation. It is the methodical, disciplined, deeply serious act of asking, given everything we know, what are the things that Behemoth could be? What set of possibilities is consistent with the observations? And which of those possibilities, if true, would have the most interesting implications? Let us walk through some of them, slowly, of course, as these things deserve. The first hypothesis, the one closest to familiar ground, is that Behemoth is an extreme stellar object, not outside the category of stars entirely, but at the absolute outer edge of it. A hypermassive star, or a cluster of stars so dense and so interconnected that at this distance they read as a single object. Multiple stellar systems bound together by gravity, burning and interacting and overlapping in ways that produce the unusual spectral signature we observe. This is not without precedent. Dense stellar clusters, particularly in the cores of galaxies or in ancient globular clusters, can produce strange collective readings. Stars so close together that their outer atmospheres are in contact, that material flows between them, that the whole system behaves like something no single star could be. It is a reasonable hypothesis. Astronomers take it seriously, and there is some evidence that points in this direction. The way certain features of Behemoth's signal seem to flicker independently of others, as if two or more distinct sources are contributing their voices to a single, complex chorus. But it doesn't fully account for all the data. The energy budget, in particular, remains stubbornly difficult to close, and the spatial extent of the object, the apparent size of it, corrected for distance, is larger than a normal star cluster of this type should be. So we move on, keeping this hypothesis in hand, but not yet resting on it. The second hypothesis brings us to something called a quasi-star. This is an object that existed, if it existed at all, only in the very early universe. A gravitational configuration so different from anything we see today that it belongs to a chapter of cosmic history we cannot directly observe. The first few 100 million years after the Big Bang. In the early universe, before the laws of star formation had settled into the patterns we now recognize, before the first generations of stars had lived and died and seeded the cosmos with the heavier elements that make subsequent stars behave the way they do, there may have been a window of time when objects of extraordinary mass could form. Not ordinary stars collapsing and compressing, something stranger. A vast cloud of primordial gas collapsing directly into a massive black hole, but not all at once. The outer layers still accreting, still falling in, while at the core, the black hole was already forming. The radiation from that accretion, the heat and light generated by matter falling into an extreme gravitational well, could be powerful enough to support the outer layers, at least for a time, creating a bloated, diffuse, intensely luminous object thousands of times the mass of the Sun. A quasi-star. If such things existed, they would have been enormous, short-lived by cosmic standards, and they would look, from a great distance, like nothing quite on our existing stellar classification chart. The question, of course, is, could one still exist? Or something like one? Something that inherited the conditions of the early universe and has persisted, somehow, against all odds, into the present epoch? The physics says no, very firmly, but the universe, as we have noted, is not always interested in what the physics says. The third hypothesis is perhaps the most immediately evocative, and perhaps the most conservative at the same time. Could Behemoth be a failed star? But at an unprecedented scale. Brown dwarfs are familiar objects to astronomers. They are objects that form through the same general process as stars, from the gravitational collapse of gas and dust, but without enough mass to ignite sustained hydrogen fusion in their cores. They glow faintly with the heat of their own formation and the slow compression of their own weight. They are, in a sense, stars that almost were. Objects that came close to that luminous threshold but did not quite cross it. Now, imagine a brown dwarf, not at the low end of the mass scale, not at the 70 Jupiter masses that defines the upper limit of known failed stars, but at a mass scale far, far beyond that. An object so enormous that it dwarfs even the largest ordinary stars, and yet which has somehow, through some mechanism we don't yet understand, failed to achieve the conditions for stable hydrogen fusion. A failed star of monstrous proportions. What would such a thing look like? What would it emit? How would it behave over time? We don't know, because we've never seen one, or rather, we may never have recognized one before. Perhaps Behemoth is the first. The fourth hypothesis, and perhaps the one that sits furthest from the shore of current scientific consensus, is the possibility that Behemoth represents something genuinely new. Not a variant of a known type, not an edge case or an extreme outlier, but a fundamentally different category of cosmic object, one that our current physics has not described, one that our current models have not predicted. There is precedent for such discoveries in the long history of astronomy. Pulsars, when they were first detected in the 1960s, produced signals so regular, so precisely rhythmic, that astronomers initially joked with a kind of terrified humor that they might be artificial. They called the first one LGM1, Little Green Men, because the signal was so unlike any known natural phenomenon that, for a brief electric moment, they entertained the possibility that it was not natural at all. Of course, pulsars turned out to be rapidly rotating neutron stars. Extraordinary, exotic, but entirely natural. The universe had simply found another way to express itself, And for a moment, humanity had been startled by the expression. What Behemoth might be, in the fourth most open-handed hypothesis, is something like that. Something the universe has been doing quietly without our knowledge, and that we are only now, with our improving instruments and our expanding reach, beginning to detect. A new form, a new category, a new word we haven't invented yet. We hold all four of these possibilities lightly. The way you hold water in cupped hands, knowing that some of it will escape no matter how careful you are, but grateful for what remains. We do not yet know which one is true. We may not know for some time. And that, strange as it may sound, is one of the most wonderful things about it. It is worth pausing here to appreciate something about the process of science itself. The generation of hypotheses, the careful, constrained, evidence-bound act of imagining what something could be, is one of the most creative acts available to the human mind. It is not imagination unconstrained, not fantasy or fiction, but imagination in dialogue with evidence, in productive tension with what the instruments have said, in active negotiation with the hard, stubborn facts of measurement. When a physicist generates a hypothesis, they are doing something that requires both rigor and freedom. Rigor. The hypothesis must be consistent with what is already known. It must not violate established physics without very good reason. It must make predictions that could, in principle, be tested. Freedom. It must be genuinely imaginative. It must be willing to go to uncomfortable places, to propose things that sound unlikely, to entertain the possibility that the universe is stranger than current models suggest. The best hypotheses hold both of these qualities simultaneously. They are disciplined and bold. They are grounded and speculative. They are, in a sense, the intellectual equivalent of tightrope walking. And the best scientists make it look effortless, which is one of the reasons we don't always appreciate how difficult it actually is. The hypotheses around Behemoth are like this. Each one is grounded in real physics, built from real observations, and each one reaches, carefully, towards something that current physics has not yet confirmed. They are the best guesses of very careful minds, and they are fascinating guesses. The kind of guesses that keep you reading. We will keep reading. We will keep measuring. We will keep looking at Behemoth with every tool available to us. And we will hold the hypotheses lightly, and we will wait for the data to tell us which of them, if any, is the one that the universe has actually chosen to enact. The waiting is part of the work. The wondering is part of the work. And the work is its own reward. Let us step off the map for a moment. Not recklessly, not in the way that abandons evidence or ignores what careful observation has given us, but in the spirit of genuine curiosity, in the spirit of wondering what lies beyond the edge of the chart, in the unmarked territory where the old cartographers used to write, "Here be dragons." Because sometimes the dragons are real. Not dragons in the literal sense, not fire-breathing monsters, but things that are so far outside our frame of reference that they might as well be things. The universe has assembled out of physics and time and circumstance using rules we either haven't discovered yet or haven't thought to apply in this particular configuration. The universe is very old. It is also very large. And in 14 billion years of expansion, in the unimaginable volume of space that has been available for matter and energy and gravity and time to work with, there is no particular reason to assume that we have catalogued all the possibilities, that we have seen every type of object, that we have run into every configuration that physics permits. We almost certainly haven't. Consider what we know about cosmic structures that resist easy categorization. Consider dark matter. the name we give to something we know is there, that we can infer from its gravitational effects, but that we have never directly detected. We know it comprises approximately 27% of the total mass energy content of the universe. It outweighs all the visible matter, all the stars and planets and gas clouds and galaxies we can see, by a factor of roughly 5 to 1. We have no idea what it is. We have theories. We have candidate particles and exotic quantum states and proposed physics beyond the standard model. We have spent decades building enormously sensitive detectors deep underground, shielded from the noise of everyday matter, trying to catch dark matter interacting with ordinary atoms. We have found nothing. Or rather, we have found nothing that we can confidently identify as the thing itself, rather than background noise or instrumental artifact. Something is there, something vast and fundamental, and we don't know what it is. Or consider the strange geography of black holes, objects whose interiors are, quite literally, beyond our ability to observe. The event horizon, the boundary past which nothing can escape, past which even the fastest thing in the universe becomes a one-way traveler, is a wall we cannot see through. Not with current physics, not with current mathematics. We know that inside a black hole our equations break down. We get infinities where physical quantities should be finite. We get nonsense where we need sense. The universe, it seems, has placed a curtain at the edge of extreme gravity and said, "Not yet." What is on the other side of that curtain? We genuinely don't know. We have proposals, string theory, loop quantum gravity, various approaches to quantum gravity that attempt to reconcile the physics of the very small with the physics of the very large. But none of them have been confirmed. None of them have produced predictions specific enough to test with current instruments. We say all of this not to be discouraging. Quite the opposite. We say it to give Behemoth the proper context. Because Behemoth, whatever it is, exists in a universe that already contains dark matter and event horizons and quantum foam and the inflationary epoch and a cosmological constant that no one can properly explain. It exists in a universe that is, at its deepest levels, still largely unknown to us. In that context, in a universe where 27% of matter is invisible and 5% is what we call ordinary matter, and 68% is the mysterious dark energy driving the universe's accelerating expansion. In that universe, the existence of an object that doesn't fit our stellar taxonomy is not shocking. It is expected. It is almost inevitable. The question is not, is the universe strange? The question is, how strange is it, and in precisely what ways? Let us try then to push the imagination a little further, to ask, what if Behemoth is not a star at all, in any sense we would recognize? What if it is something operating on a different principle entirely? There are physicists who have proposed the existence of objects called gravitational stars, or gravitars, hypothetical entities that would look, from the outside, like black holes, but would not have a singularity at their center. Instead, they would be held in a kind of extreme static equilibrium by quantum effects, balanced on the razor edge between collapse and coherence. They would glow, they would radiate, and the radiation they produced would not look like the radiation from a conventional star. These are not mainstream proposals. They are edge-of-science ideas. But they are ideas that emerge from genuine physics, from the attempt to solve real problems. And if such an object existed at an enormous scale, if the gravitational equilibrium could be maintained across dimensions that dwarf any stellar mass, then something like Behemoth might be the result. Or consider the possibility, even more speculative, even further from the shore, that Behemoth is a structure. Not a natural object in the sense of something assembled by gravity and nuclear physics alone, but a configuration of matter so improbable, so geometrically unlikely, that it raises questions that scientists are deeply uncomfortable asking. Questions about what shaped it, about why it has the particular form it has, about whether the universe in certain places, under certain conditions, can produce things that look less like natural phenomena and more like something else. We are not saying that. We are not implying it. We are saying only that these thoughts arise in the dark when you have been looking at the data long enough. These thoughts are not science, but they are part of the human experience of doing science. The place where rigor brushes up against wonder, where method encounters awe, where the instruments fall silent and the mind keeps going. We have a word for it in astronomy when an object resists classification, when the data comes back and it doesn't fit the models, and the scientists sit back and say, when the measurements are real, but the interpretation is genuinely unclear. When the universe has handed us a new piece of a puzzle and we're not certain which puzzle it belongs to, we call it a mystery. And we mean that in the deepest, most respectful sense of the word. Not a mystery in the sense of a crime novel, not a puzzle with a solution already waiting, already known to someone else. A mystery in the old sense, in the sense of something sacred and sealed and immense, something that you approach with care and appropriate humility. Behemoth is a mystery. And mysteries in science are not failures. They are invitations. Let us follow that thought a little further, because the word invitation implies a direction. It implies that somewhere, something is waiting to be found, and that sense of direction, the orientation of inquiry toward the unknown, is one of the things that makes science feel, at its best, like an adventure. Not in the dramatic, explosive sense, in the quieter sense, the sense of setting out across unmarked territory with the best tools available and the fullest preparation possible, knowing that you cannot predict what you will find. The instruments that have shown us Behemoth are remarkable things in themselves. Each wavelength window we have opened onto the universe has revealed something that optical observation alone could never have shown us. Radio telescopes listening to the long, slow oscillations of cold gas and spinning pulsars. Infrared detectors seeing through dust clouds to the stars forming inside them. X-ray observatories in orbit above the atmosphere, detecting the fierce energies of accretion disks and neutron star surfaces. Gravitational wave detectors, their mirrors separated by kilometers, sensitive to distortions of space-time, smaller than a proton's width. Each one a different language, each one adding vocabulary to our account of the universe. And yet, even with all of these, even with the full electromagnetic spectrum at our disposal, plus the new senses of gravitational waves and neutrino detection, Behemoth remains partially unresolved. It speaks in multiple frequencies and the combined voice is complex. It tells us some things clearly and other things not at all. It is generous with its emissions and stingy with its explanations, which is, of course, how the best mysteries behave. They give you enough to be compelled, not enough to stop looking. They keep you at the table reaching for one more piece of evidence, one more measurement, one more angle of approach. They keep the instruments running through the night while the planet turns beneath them, and the sky rotates and Behemoth holds its position among the stars, patient and enormous, and completely indifferent to our curiosity. The universe has produced something we don't understand. That is not new. The universe is full of things we don't understand, full of them, crowded with them, overflowing with the magnificent excess of its own complexity. What is new is this particular thing, this particular configuration of matter and energy and whatever else may be involved, this particular signal arriving in our instruments from a particular point in space and time. We have not seen this before. That is extraordinary, and we should sit with the extraordinariness of it, at least for a moment, before we rush to resolve it. Before we find the explanation and file it away and move on to the next mystery. Because there is something irreplaceable about the moment of encounter, the moment before understanding, the moment when the thing is still itself, still fully unknown, still carrying the full weight of its own inscrutability. This is that moment for Behemoth. We are in it. We are grateful to be in it. There is a particular feeling that comes with looking at the universe for too long. It is not quite dizziness. It is not quite grief. It is something adjacent to both. A kind of vertigo of meaning, a sense of the ground shifting beneath your feet, without any literal movement at all. Scientists feel it. Philosophers feel it. Poets have been trying to describe it for as long as there have been words. It is the feeling of encountering the actual scale of things and having your ordinary, human-sized sense of proportion quietly collapse under the weight of it. The universe is approximately 13.8 billion years old. In that time, it has expanded from a state of almost unimaginable compression. Everything, all of it, in a region so small it would shame a subatomic particle, to its current extent, which is so large that the light from the most distant observable galaxies has been traveling since the universe was young and is only now reaching us, after a journey of nearly 14 billion years. And this is only the observable universe, the part we can, in principle, detect. The full universe, if such a thing even has a boundary, may be far, far larger. Perhaps infinite, we don't know. The word infinite is available to us mathematically, but what it means experientially, philosophically, as a fact about the actual space in which we exist, that is something no human has ever truly grasped, and perhaps no human ever can. What we have, what our instruments have given us, is a window of extraordinary power compared to what our ancestors possessed. We can see things that are billions of light years away. We can detect gravity waves, ripples in the fabric of space-time itself, produced by black holes merging billions of years ago in some distant galaxy. We can read the composition of a star's atmosphere from the light it emits across inconceivable distances. We can map the large-scale structure of the universe, the vast web of filaments and walls and voids along which the galaxies are arranged, like dew on an invisible cosmic spider's web. These are magnificent achievements. They represent centuries of accumulated work, of instrument building and mathematical refinement, and the very human willingness to devote a life to looking at things that have no direct bearing on survival, no immediate practical value. Things that matter only because they matter, only because knowing is its own kind of nourishment. And yet, the window is still a window. No matter how large it is, it has edges. And beyond those edges, beyond the boundary set by the speed of light and the age of the universe, beyond the resolution limits of our instruments and the mathematics that has been developed so far, is more. Vastly more. An ocean of the unknown that dwarfs the bright, mapped regions we have explored. Humans have been observing the sky for as long as there have been humans. There is evidence in cave paintings, in the alignments of stone structures, in the myths and calendars of the oldest cultures we know of, that our ancestors were looking up long before they had any tool more sophisticated than their own two eyes. Long before lenses and mirrors and photographic plates and charge-coupled devices and radio, telescopes and gravitational wave detectors. They were looking up and they were wondering. and they were building stories to hold the wonder in. Stories about gods and monsters and heroes written in the stars. Stories that were their best attempt to give meaning to the incomprehensible. The stars were not random to them. They were a language, and learning to read that language was one of the earliest and most persistent of human intellectual projects. We have come a long way since then. The language we read now is mathematics rather than mythology, spectroscopy rather than storytelling. But the impulse is the same. The impulse to look and to wonder and to reach for some account of what is actually out there. Some description that is not just beautiful, but true. That impulse is unchanged. It is as old as the species. It may be what makes us the species we are. What Behemoth reminds us, what the best mysteries always remind us, is that we are still at the beginning. This is not a despairing statement. It is an exhilarating one. To be at the beginning means that most of the extraordinary things have not yet been found. Most of the jaw-dropping discoveries have not yet been made. Most of the concepts that will transform how we understand the universe have not yet been thought. Most of the instruments that will show us things we currently cannot imagine seeing have not yet been built. The history of science is a history of moments when something that was thought to be fully understood turned out to be only the first page of a much longer story. Newtonian mechanics, a towering achievement, the foundation of an entire worldview, turned out to be an approximation. A very good approximation, accurate enough to send spacecraft to the edges of the solar system, but still an approximation. The deeper truth, revealed by Einstein, was weirder and stranger and more beautiful and more unsettling than Newton could have imagined. Quantum mechanics, in turn, revealed that at the smallest scales, reality behaves in ways that even its founding theorists found deeply disturbing. Niels Bohr supposedly said, though the attribution is disputed, that anyone who is not shocked by quantum mechanics has not understood it. The point stands. Reality, when you look at it closely enough, does not behave the way common sense suggests it should. It behaves the way it actually does, which is more strange and more interesting than common sense allows for. Behemoth belongs in this tradition. It is the universe, once again, pointing at itself and saying, "You've been drawing the map too small. There's more here than you've accounted for. There's more here than your current tools are equipped to describe. We are still learning how to see." This is not a failure, it is the condition of all honest inquiry. The acknowledgement that what we know is a lamp carried into a vast and largely dark room, illuminating the space immediately around us with extraordinary clarity, but unable, from here, to reach the far walls. We keep moving, we keep lifting the lamp, we keep expanding the pool of light, centimeter by centimeter, year by year, discovery by discovery. And every now and then, the lamp catches something that was not supposed to be there. Something that doesn't fit. Something like Behemoth. And we stop. And we look. And we feel in that moment simultaneously very small and very alive. Very ignorant and very grateful for what we don't yet know. Because the not knowing is where all the good questions live. And the good questions, the ones that keep you up at night, the ones that remake the world when they are finally answered, are the most precious things we have. There is a concept in philosophy of science sometimes called the horizon of knowledge, the boundary between what is currently known and what lies beyond current understanding. Every era of human inquiry has such a horizon. Every generation of scientists operates within a horizon that is defined partly by the instruments available to them, partly by the mathematical tools, partly by the conceptual frameworks they have inherited, and partly by the sheer accidents of what has and hasn't been noticed yet. The horizon moves, This is the fundamental optimism at the heart of science. The belief, borne out repeatedly across the history of inquiry, that the horizon can be pushed, that the boundary can be expanded, that the territory of the known can grow, year by year, decade by decade, until what was once the edge of the map is now comfortably within the mapped region, and the new horizon is further out, into territory that the previous generation couldn't even imagine. The people who will ultimately understand Behemoth may not yet have been born. The instruments they will use to study it may not yet have been designed. The mathematical language in which the explanation will be written may not yet have been developed. This is not a reason for despair. It is a reason for profound, forward-reaching hope. The work we do now, the measurements, the hypotheses, the careful accumulation of data and the honest reporting of what it does and does not tell us. All of this is the foundation on which those future explanations will be built. We are not just observers, we are contributors. The data we collect becomes part of the record. The questions we ask become part of the conversation. The anomalies we flag and follow, the things that don't fit, the behemoths of our moment. These become the threads that later hands will pull on, patiently, until the larger picture comes clear. Science is not a solitary act. It is a vast, multi-generational collaboration. A conversation across centuries carried on in papers and instruments and apprenticeships and arguments and late-night calculations and the slow, patient transfer of hard-won understanding from one mind to the next. We are all participants in it. Everyone who has ever looked up and wondered is part of it. You are part of it. Right now, in this moment of watching and wondering and letting the mystery of Behemoth sit in your mind and do whatever it does there, you are part of the conversation. Your curiosity is not passive. It is generative. The questions you carry with you, the wonder you feel, the willingness to sit with the not knowing rather than rushing to a false resolution. These things matter. They have always mattered. They are what keeps the work alive. We are still learning how to see, and we are doing it together. We have come a long way tonight. We have moved through the foundations of what we know, through the patient, beautiful, hard-won science of stars and their lives and their deaths. We have visited the edge of that knowledge, the place where the known territory gives way to the suspected and the speculative. We have looked at Behemoth from several angles through several lenses, with several different frameworks. We have asked, what could it be? And now, at the end of all of that, at the end of our walking and our wondering, we are going to do something that is perhaps the most difficult thing in science. We are going to leave the question open. This is harder than it sounds. There is something in the human mind, something deep and old and extremely persistent, that craves resolution, that wants the story to end, the question to be answered, the file to be closed, and the case to be settled. We feel it in the satisfaction of a well-resolved piece of music, in the particular relief of a story's final page, in the comfort of knowing. Science, at its best, resists this craving. Not permanently. Science is ultimately in the business of finding answers, but it resists the premature closure of questions that are not yet ready to be closed. It insists on the discipline of sitting with uncertainty, of saying we don't know yet, of meaning it, of not pretending otherwise. Is Behemoth a star? We don't know. It may be a star, an extreme stellar object at the outermost edge of what physics permits. Or it may be a cluster of stars, a dense assembly of bright objects that reads, at this distance, as a single incomprehensible source. It may be something from the early universe, a relic, a survivor, an object that formed under conditions that no longer exist and has somehow persisted into the present epoch, unchanged or barely changed, like a living fossil of the cosmos. Or it may be something genuinely new, something we have not yet thought of a name for, something that will, when it is properly understood, require us to revise our models, reprint our textbooks, and look back at the old category of star with the same gentle, retrospective fondness that we look back at the flat Earth. Not with condescension, but with the recognition that every framework, no matter how good, eventually grows too small for what comes next. There is a particular quality to the questions that don't have answers yet. They vibrate differently from the ones that do. They have a kind of aliveness, a kind of ongoing presence in the mind, a way of surfacing at unexpected moments. In the shower, in the space between sleeping and waking, on a clear night when the stars are out and you find yourself standing still for a moment longer than you meant to. What is that? You find yourself thinking, looking up at some particular point of light. What is actually out there at the end of all that distance? What is the universe doing right now in the places no one has looked? These are old questions. They are the same questions our ancestors asked when they lay on their backs in the grass and looked at the Milky Way, before they knew what the Milky Way was, before they knew it was a galaxy, before they knew there were other galaxies, before they knew the universe was expanding and accelerating, and that its visible portion was only a small fraction of what might exist. They looked up and they felt the exact same feeling that you can feel right now if you choose to. That feeling has no name, or rather, it has many names. In many languages, none of them quite adequate. Awe, vertigo, wonder. The German word Weltschmerz comes close. The ache of the world, the particular pain of knowing that the world is larger than your ability to hold it. There is a Japanese concept, mono no aware. The bittersweet awareness of impermanence, the poignant recognition that beautiful things pass. There is the Portuguese saudade, a longing for something distant or gone. The feeling of looking at Behemoth, of sitting with the question of what it is, borrows from all of these and from none of them completely. It is its own feeling, the feeling of the edge of knowledge, the feeling of the last page of the map. We believe, and this is not a scientific claim, it is a human one, that this feeling is important, that sitting with it rather than rushing past it to the next thing has value. Not just instrumentally, not just because it makes you a better scientist or a more curious student or a more creative thinker, though it may do all of those things, but intrinsically, for its own sake, because this is what it means to be a conscious creature in an incomprehensibly vast universe. This is what it means to be, as far as we know, the part of existence that can reflect on existence. The part that has evolved through billions of years of improbable, contingent, deeply weird biological history, to the point where it can look at a distant, mysterious object and say, "I wonder what you are." That is extraordinary. That is perhaps the most extraordinary thing about us. Not the technology, not the mathematics, not the instruments or the models or the peer-reviewed papers. The wondering itself, the bare, pre-theoretical, deeply felt capacity to stand before the unknown and find it beautiful. Is Behemoth a star? We have asked this question tonight in many forms and from many angles. We have approached it through the science of stellar physics and through the philosophy of knowledge and through the quiet, slow, meditative attention that the universe deserves when you look at it honestly. And the answer for now, the only honest answer available to us, is we don't know. Something is out there, something immense and ancient and strange, something that sits in our data and resists our categories and glows with a light we haven't fully learned to read. something that has been there, burning or not burning, or doing something we don't yet have a verb for. Long before any human looked up at the sky and wondered. It will be there after we have found the answer, and after the answer has been incorporated into science and taught in schools and made familiar, and eventually superseded by an even deeper question that it turns out to be pointing toward. The universe is not in the business of running out of mysteries. It is not going to let us draw the final line on the final map. Every answer is a new set of questions, and the questions go all the way down and all the way out, and perhaps, if the cosmologists and the philosophers are right about some things, all the way around again in ways that make the words out and down stop meaning what they usually mean. So, we leave you here, in the quiet, with the questions still warm in your hands. Look up tonight if the sky is clear where you are. Find the darkest patch you can. Give your eyes a few minutes to adjust. Let the stars come out. Somewhere in all of that light, far beyond what any eye can see, in a region of space that would take a beam of light millions or billions of years to reach. Behemoth is there, doing whatever it is that Behemoth does, being whatever it is that Behemoth is. It does not need us to understand it. It does not require our attention to continue existing. The universe was getting along fine before we arrived, and it will get along fine after we are gone. And yet, because we are here and because we have these minds, and because we have built these instruments and these theories and this long, luminous tradition of looking and wondering and trying to know, we have caught a glimpse of it. We have turned our attention, briefly, towards something vast and strange and unresolved. And in that turning, in that willingness to look at what we don't understand and sit with the not understanding, we have done something quietly remarkable. We have been curious. We have been human in the best possible way. And the question, is Behemoth a star or something else, lingers on, unanswered, open, alive. We want to tell you before we go about a thought that has accompanied the making of this video. A thought that arrived early in the process and didn't leave. When you stand at the edge of knowledge, when you look at something like Behemoth, something that resists your understanding, something that sits at the absolute limit of what your instruments can tell you and your models can accommodate, there is a temptation toward two equally unhelpful responses. The first is to pretend certainty you don't have, to fill the gap with confident-sounding speculation, to pick one of the hypotheses and present it as the answer, to reassure yourself and your audience that it's figured out, or nearly figured out, that someone somewhere has the explanation well in hand. This is the temptation of comfort, of the false resolution, of the story that ends before it should, tied up too neatly, the bow slightly too tidy. The second is to collapse into paralysis, to be so overwhelmed by the not knowing that you stop engaging, to decide that since nothing can be said for certain, nothing is worth saying at all. This is the temptation of false humility, of throwing up your hands, of retreating from the question because the question is hard. The middle path, the one we have tried to walk tonight, is harder than either of those, and more rewarding than both. It is the path of active, engaged, honest uncertainty. The path of saying, here is what we know. Here is what we don't know. Here is the shape of the question. Here are the possible shapes of the answer. And here is why it matters that we keep looking. That middle path requires a particular kind of intellectual courage. The courage to be publicly uncertain. To say, on camera, in front of however many people are watching, we don't know. And to mean it without embarrassment. To wear the not knowing as a badge not of ignorance, but of honesty, of rigor, of the determination not to close a question before it is ready to be closed. There is one more thing we want to say about Behemoth, about what it represents beyond its own particular mystery. Every generation of people who have looked at the sky has looked at a different sky, not different in itself. The stars are old, the universe is old. Behemoth has been there far longer than any human civilization has existed, but different in what could be seen, different in what was visible to the instruments of the time, different in what could be extracted from the light. The ancient astronomers who tracked the planets across the sky, who noticed that certain lights moved against the fixed background of stars, and who mapped those movements with extraordinary precision, using nothing but the naked eye and patient observation. They were looking at the same sky. They were seeing real things. The planets they tracked were real. The patterns they found were real. Their knowledge was genuine and hard-won and, in many respects, extraordinary. But they could not have imagined Behemoth. They could not have conceived of an object at that distance, at that scale, producing those kinds of signals. The universe they inhabited, the universe their instruments and their mathematics could reach, was simply too small to contain it. Not because it wasn't there, because the tools to see it didn't yet exist. We are in a better position now than they were. We can see further. We can detect more. Our instruments have senses that human evolution never equipped us with. We can see in X-ray and radio and infrared and ultraviolet. We can feel the vibrations of space-time. We can detect the ghostly whispers of neutrinos passing through the Earth as if it weren't there. We have extended ourselves as a species far beyond the biological limits of our perception. And still, Behemoth resists us. Still it sits at the edge of what we can clearly see. Still it presents us with a signal we can detect, but not fully interpret. Still it occupies the category of mystery, which means that whatever generation finally understands Behemoth, and they will eventually understand it, they will have tools and frameworks and ways of thinking that we cannot yet imagine. They will look back at this moment, at us, straining towards something with our best instruments, generating our most careful hypotheses, committing ourselves to the honest uncertainty of not knowing. And they will feel, perhaps, the same generous affection that we feel for those ancient stargazers, the same recognition of shared endeavor, the same gratitude for the work that was done, imperfectly, with the tools available, in the spirit of genuine curiosity. They will understand Behemoth, and then they will turn toward whatever mystery is waiting for them at the edge of their horizon, because that is what this is. That is what we are, the species that moves toward the edge, the species that finds the edge and keeps going, that builds instruments to see past what the eye can manage, and builds mathematics to describe what the instruments find, and builds hypotheses to interpret what the mathematics suggests, and builds new instruments to test the hypotheses, and always discovers that there is more. There is always more. The question hangs in the air above us now the way a good question should, unresolved, patient, slightly luminous in the dark. Is Behemoth a star? Is it something else? Is it something we don't yet have language for? Something waiting quietly at the edge of our knowledge for the moment when we have developed the tools and the concepts to truly see it? We don't know, but we are looking. And the looking, the ongoing, patient, wonder-filled, instrument-aided, hypothesis-generating, evidence-testing, beautifully imperfect looking, is perhaps the most important thing about us. Perhaps the most important thing in the universe is that part of it looked back at itself and asked, "What are you?" And then kept asking, and then kept looking for the answer. If you've stayed with us this far, if you've let the journey from that first glimpse of something unnamed and enormous to this final fading into quiet do, whatever it has done to you, then you already understand something that is hard to teach and impossible to force. You understand what it feels like to be genuinely uncertain about something vast, to sit with a question bigger than any answer you currently have, to look at the universe, at the real universe, the actual one, the one that exists independently of our wishes and our models and our well-intentioned theories, and feel the specific, irreplaceable sensation of not knowing. It is an unusual feeling. Most of our daily lives are organized around the management of uncertainty, around the creation of routines and structures and expectations that reduce the number of unknowns we have to cope with at any given moment. Uncertainty in ordinary life is stress. It is the thing you try to minimize, the thing that keeps you up at night in the bad way, the thing that you manage and mitigate and build plans to defend against. But cosmic uncertainty, the uncertainty of Behemoth, the uncertainty of what lies beyond the edge of our instruments and our models, that is a different kind of uncertainty. It is not threatening. It has no consequences for your morning or your bank account or the relationships you depend on. It is pure uncertainty. Uncertainty unattached to stakes. Uncertainty as raw material, as possibility, as the stuff from which discoveries are eventually made. And in that purity, there is something surprisingly peaceful. Something that, if you let it, can reorganize your sense of what matters and what doesn't. When you hold in mind the fact that somewhere in the universe, there is an enormous, mysterious object that we have not yet managed to classify, that may represent a genuinely new category of cosmic phenomenon that is carrying on its existence entirely indifferent to our attempts to understand it. When you hold that in mind, certain things that felt urgent a moment ago begin to feel less so. Certain anxieties that seemed enormous shrink, not because they're not real, but because the frame has gotten larger. This is what the best science communication does at its finest. Not just inform, not just educate, not just transfer facts from one set of neurons to another, but reframe, expand the context. Make the frame of reference large enough that the ordinary problems of ordinary life are held in their proper proportion, neither ignored nor magnified, but seen in relation to something genuinely immense. Let us talk about distance for a moment, because distance is one of the most emotionally interesting features of what we've been discussing, and we've touched on it, but not fully explored it. The distances in astronomy are so extreme that even the units we use to measure them have to be invented specifically for the purpose. Kilometers, as we've said, break down quickly. They are too small for the job. So astronomers use the astronomical unit, the AU, the distance from the Earth to the Sun, about 150 million kilometers, as a baseline for the solar system. The nearest star to our Sun, Proxima Centauri, is about 270,000 astronomical units away. Already the astronomical unit feels inadequate. So we move to the light year. The distance light travels in a year, moving at 300,000 kilometers per second without stopping, without slowing, covering more than 1 trillion kilometers in 12 months. Proxima Centauri is about 4.2 light-years away. Our Milky Way galaxy spans roughly 100,000 light-years from one edge to the other. The Andromeda galaxy, the nearest large galaxy to our own, is approximately 2.5 million light-years away. The light arriving in your eye from Andromeda right now left that galaxy before modern humans existed. Before Homo sapiens had developed language, or art, or the capacity for the kind of sustained abstract thought that eventually produced astronomy. And Behemoth is beyond all of that. The light from Behemoth that has reached our instruments set out on its journey long, long ago. In some cases, so long ago that the civilization that would eventually receive it hadn't evolved yet. That hadn't even begun to evolve. That was nothing yet. Just the vague, unimaginably distant possibility of carbon-based life on a yet-to-be-formed rocky planet orbiting a yet-to-ignite star in a galaxy that was still in the process of assembling itself. By the time the light from Behemoth arrives at our instruments, it carries information about a state of affairs that no longer exists in the same form. Because at those distances, the travel time for light is so long that we are not seeing what Behemoth is now. We are seeing what it was long ago when that light began its journey. In a very real sense, every deep sky observation is an act of archaeology. We dig into the past with our telescopes, we excavate ancient light, we read the records left by the universe at various points in its own history. What is Behemoth doing right now? We cannot know. We cannot know in the same way that you cannot know what a message says before it has arrived. The information is in transit. It will reach us, or rather it will reach our descendants and their instruments, millions or billions of years from now. And what they observe will be Behemoth as it is in their present, which is Behemoth as it will have been for all that time. We are, in a sense, reading a letter written before we were born. A letter from an object whose present we will never directly observe. And yet, the letter is real, and the reading is real, and the act of deciphering it, of trying to understand what it says and what sent it and what it means, that is as real and as meaningful as any act of understanding can be. There is a philosophical tradition, old, branching into many forms and schools, but persistent, that finds meaning in the simple act of observation. Not in the conclusions that observation leads to, not in the theories it confirms or refutes, but in the act itself, in the turning of attention towards something, the willingness to look carefully, the discipline of sustained attention over time. This tradition has parallels in the scientific practice of patient, careful observation. In the long hours at the telescope, the repeated measurements, the refusal to rush to interpretation. It is what the philosopher Simone Weil called attention, a specific quality of mind directed without agenda, receptive rather than grasping, present rather than rushing ahead to conclusions. We cannot claim that scientific observation is the same as what Weil had in mind. But there is something in the best science, in the work of people who give their working lives to studying one small corner of the universe with extraordinary patience and care, that resembles it. Something in the quality of attention brought to an object like Behemoth that is more than mere data collection, something that is, perhaps, a form of reverence. Behemoth does not benefit from our attention. It does not become more or less whatever it is based on whether we look at it, but we benefit. We are changed by the looking. We are enlarged by it, the universe that we carry inside us. The model of reality that each of us constructs from everything we have ever experienced and learned and felt becomes, with each genuine encounter with the immensity of things, a little larger and a little more true. And that seems to us like something worth doing, worth spending an evening on, worth devoting a YouTube channel to, worth sitting with, even after the video ends and the room comes back, and the ordinary world reasserts itself with all its small demands and necessary practicalities. Because the universe doesn't go away. It doesn't stop being enormous when you close the tab. It is always there, beyond the ceiling, beyond the atmosphere, beyond the reach of every eye and every instrument we currently possess, going about its incomprehensible business, producing phenomena we have not yet imagined, carrying the light of objects we have not yet named. And somewhere in all of that, quiet, distant, enormous unknown, Behemoth persists. We want to say one last thing before we truly let you go. One last small thought to carry with you into the night. When the first systematic surveys of the deep sky were conducted, when early astronomers began to catalogue what they saw, to organize the zoo of objects the universe presents at various wavelengths and distances, there was a recurring experience that many of them described. Not in scientific papers where such things are not easily accommodated, but in letters and diaries and conversations. The experience of standing at an instrument and suddenly feeling, not understanding feeling, the sheer scale of what they were looking at. One astronomer described it as the sensation of falling, but upward. Another called it a kind of organized vertigo that you learn to live with because it never entirely goes away. A third, more poetically inclined, compared it to standing at the edge of the ocean as a child. The way the ocean doesn't stop at the visible horizon, the way you know it extends far beyond what you can see, and the way that knowledge gives the surface in front of you a different quality, a depth, a weight, the presence of all the invisible water behind the visible waves. That is what Behemoth gives us, we think. That additional depth, that weight of the invisible. The awareness that what we can see, what our instruments can detect, what our models can describe, is the surface of something that extends far, far beyond. Something that was here before us and will be here after us. Something that holds its own nature quietly and completely, and without any particular regard for whether we manage to understand it. The universe is not keeping secrets from us. It is not withholding. It is simply being itself in all its impossible complexity. And we are the part of it that is trying to learn how to see clearly enough to read what is there. We are getting better at it. We have been getting better at it for thousands of years. We will continue to get better at it for as long as there are curious minds with instruments and mathematics and the willingness to sit with hard questions. Behemoth will be understood one day, and on that day we will turn to the next behemoth, the next thing that doesn't fit, the next signal that resists interpretation, the next enormous, ancient, quietly inscrutable object that sits at the edge of our understanding and waits with the infinite patience of something that has been here since before we existed, for us to catch up. And we will catch up, because that is what we do. That is perhaps the most magnificent and most hopeful thing about us. We catch up, and then we reach for what is further still. Bow. Nose. Chapter the instruments that found Behemoth. And what they tell us we have spoken throughout this video about instruments, about the tools that allow us to see Behemoth at all, the mechanisms by which we extend our reach across distances so vast that ordinary language can barely describe them. But we haven't yet spent time with those instruments themselves, with what they actually are and what it took to build them, and what it means that we have them at all. Because this too is part of the story. The instruments are not merely means to an end, they are achievements in their own right. Milestones in the long, slow project of humanity trying to see further and more clearly than its biological equipment alone would allow. And understanding them, even in broad outline, even without the engineering details, deepens the encounter with what they show us. So let us talk about how we see. The human eye is a remarkable instrument. In the context of evolutionary biology, it is extraordinary. A complex optical system assembled by natural selection over hundreds of millions of years, capable of detecting an astonishing range of light intensities, capable of resolving detail at multiple distances simultaneously, capable of the color discrimination that lets us navigate a world of extraordinary visual richness. We take it for granted as we take most of our capabilities for granted. But step back from the familiarity of it, and the eye becomes a source of genuine wonder. And yet, as an astronomical instrument, the eye is severely limited. It is sensitive to only a tiny sliver of the electromagnetic spectrum, the narrow band of wavelengths we call visible light, roughly from 380 to 750 nanometers. Everything outside that band is invisible to us without technological assistance. The radio waves that carry information across the universe. The microwaves that constitute the cosmic microwave background. The afterglow of the Big Bang itself, the oldest light in the universe, now stretched to microwave wavelengths by the expansion of space. The infrared radiation emitted by objects too cool to glow visibly, but very much present and active. The X-rays that pour from the environments of neutron stars and black holes and galaxy clusters. The gamma rays released in the most energetic events the universe produces. All of this is happening, constantly, in every direction, and to the naked eye it is completely invisible. When we look at the night sky with our eyes alone, we are seeing the universe through a single, narrow keyhole. What lies on the other side of that keyhole is magnificent, genuinely, achingly magnificent. And looking at it with the naked eye on a clear, dark night, far from city lights, is one of the most profound available human experiences. But it is a tiny fraction of what is actually there to be seen. The telescope, when it arrived in the early 17th century, represented the first great extension of human optical reach. By gathering more light than the pupil alone can collect, by focusing and magnifying, the telescope allowed observers to see things that were genuinely invisible to the unaided eye. Moons of Jupiter, the phases of Venus, the innumerable stars of the Milky Way, resolving from a faint, diffuse glow into individual points of light. The craters and mountains of the Moon, transformed from a flat disk into a three-dimensional world. But the telescope, for its first few centuries, remained a strictly optical instrument. It still saw only visible light. It still looked through that same narrow keyhole, only further. The universe beyond visible light remained inaccessible. The 20th century changed everything. In rapid succession, by the standards of the long history of astronomy, new windows opened onto the universe. Radio astronomy emerged in the 1930s from the accidental discovery by Carl Jansky that the center of the Milky Way emits radio waves. Infrared astronomy developed as detector technology improved. X-ray astronomy became possible only when instruments could be placed above the Earth's atmosphere, which blocks X-rays, first on rockets and then on orbital satellites. Gamma-ray astronomy followed, ultraviolet astronomy, and with each new window, the universe looked different, more complex, more energetic, more various. Objects that had appeared quiet and unremarkable in visible light turned out to be screaming with activity in X-rays. Cold regions of space that produced no visible light at all glowed brightly in the infrared, revealing the temperatures of star-forming clouds and the warm dust surrounding young planetary systems. The radio sky showed a landscape of pulsars and quasars and radio galaxies that optical observation had given no hint of. Each new window was a revelation. Each one said, in effect, you thought you had a reasonably complete picture. You did not. Here is more. Here is what was there all along, waiting for you to develop the sense that could detect it. The detection of Behemoth required several of these windows to be opened simultaneously. It required the kind of multi-wavelength observation that has become a hallmark of modern astronomy. the cross-referencing of data from different parts of the spectrum, the attempt to build a composite picture from multiple kinds of information, the recognition that no single wavelength tells the whole story. In the visible, Behemoth appears as a faint, slightly extended source. Something that doesn't quite look like a point star, but doesn't quite look like a galaxy either. Its colors in the visible spectrum are unusual. Too blue in some bands, too red in others, as if the source is made of components that don't quite belong to the same population of objects. In the infrared, it brightens significantly, more than you'd expect from a stellar source of this distance. The excess infrared emission suggests the presence of warm material, dust, perhaps, or gas, at temperatures that produce infrared rather than visible radiation. The shape of the infrared emission, the way its intensity varies across different infrared wavelengths, is one of the features that most challenges interpretation. It doesn't match the profiles of known dust emission cleanly. Something else seems to be contributing. In X-rays, Behemoth is also detected, and X-ray emission is particularly interesting because it typically requires either very high temperatures, millions of degrees, or the presence of extreme gravitational fields that accelerate particles to relativistic speeds. The X-ray luminosity of Behemoth is significant. Not overwhelming, not in the class of the most powerful X-ray sources in the sky, but present, steady, and spectrally unusual. The hardness of the X-ray spectrum, the ratio of high energy to low energy X-ray photons, doesn't match standard templates for any of the obvious source types. In the radio, the picture is different again. Radio emission from Behemoth has been marginal, at the edge of detectability with current instruments, but what has been tentatively detected suggests a non-thermal spectrum, emission that doesn't arise from the thermal jiggling of hot gas, but from some process involving charged particles moving in magnetic fields. Synchrotron radiation, most likely, the kind produced when relativistic electrons spiral along magnetic field lines. This is a signature that appears in a range of contexts: supernova remnants, active galactic nuclei, pulsar wind nebulae. It is not unique to any one type of object, but its presence, combined with the other wavelength data, adds another layer to the complex portrait we are assembling. And then there is the time domain, the temporal behavior of Behemoth, tracked over the years during which it has been observed, because the universe is not static. Objects change, vary, flicker, pulse, brighten, dim. The way something changes over time is often as informative as its average properties. A variable star and a constant star of the same average brightness are very different objects. Their variability, or lack of it, tells you something fundamental about the physics going on inside them. Behemoth's variability has been mentioned, but it deserves more attention. Because the variability is not random. It is not the kind of flickering you'd associate with instrumental noise or atmospheric effects. It is real variability, intrinsic to the object, with structure that we can partially resolve but not yet fully explain. There are timescales in the data, periodicities that emerge when you look at the right frequency range, suggestive of some underlying regular process. But the periods don't line up with any simple model. They are not the pulsation periods of variable stars. They are not the orbital periods you'd expect from a binary system of any plausible configuration. They are something else, something that is telling us about a physical process we have not yet identified. The time domain data is perhaps where the next breakthrough will come. As observing programs continue, as the baseline of observations grows longer, as more points are added to the light curve, patterns that are currently ambiguous may become clear. The signal-to-noise will improve. What now looks like structured noise may resolve into a genuine, identifiable rhythm. the heartbeat of a process we can finally name. Or it may not. It may remain complex and difficult and resistant to simple interpretation. The universe has no obligation to be easy. We want to say something about the people who built the instruments that detected Behemoth, not the famous figures, not the names you find in textbooks. The people behind the people. The engineers who designed the optical systems and the detector arrays and the cryogenic cooling systems that keep the infrared sensors at temperatures cold enough to prevent their own thermal emission from swamping the signal. The software developers who wrote the pipelines that process the raw data. The billions of measurements that arrive from each observing run, which must be cleaned and calibrated and corrected for systematic effects before they can be usefully analyzed. The technicians who maintain the instruments through the long hours of the night, making sure the tracking systems are functioning and the domes are open and the calibration sources are running. These people are, in a very real sense, part of the discovery of Behemoth. Their work, unglamorous, careful, sustained, essential, is what makes it possible to say, we detected something. We have data. We know it is real. Without the accumulated effort of thousands of people across decades of instrument development and refinement, Behemoth would simply not be in our awareness. It would be there as it has always been there, but we would not know. This is one of the things about modern science that is hard to convey in a documentary format. The scale of the collaborative effort, the number of people whose contributions are necessary, the length of the causal chain between the first insight that a certain kind of observation would be valuable and the final publication of a result. It is not the work of lone geniuses, dramatic eureka moments, singular visionaries. It is the work of communities, of institutions, of sustained, funded, organized, rigorous collective effort over long timescales. And it is beautiful. In its own way, it is one of the most beautiful things human beings do. This deliberate, patient, multi-generational project of trying to understand the universe we find ourselves in. This willingness to build instruments that will produce their best results decades after the people who designed them have retired. This trust in the future, the act of doing careful work now whose full value will only be realized by people who are not yet born. Science is an act of faith in the future, of confidence that there will be minds in times to come to receive what we are carefully preparing to hand them, that the knowledge being built now will find its audience, that the questions being asked today will, eventually, have their answers, even if none of the people currently asking them will be there to see it. Next-generation instruments are already in development that will change what we can know about objects like Behemoth. The extremely large telescope, currently under construction in the Atacama Desert of Chile, will have a mirror 39 meters across, large enough that, when it opens its eye to the sky, it will gather more light in a single second than any existing telescope collects in an hour. Its angular resolution will be sharp enough to see, in principle, individual stars in galaxies tens of millions of light-years away. It will be able to take spectra, detailed chemical and physical fingerprints of objects that current instruments can barely detect. Space-based observatories planned for the coming decades will extend our reach in wavelengths that the atmosphere blocks. New X-ray telescopes will dramatically improve our ability to study high-energy phenomena. Future gravitational wave detectors, both ground-based and space-based, will open an entirely new sense. One that doesn't rely on electromagnetic radiation at all, that detects the ripples in space-time produced by massive accelerating objects. This sense, still in its infancy, has already transformed our understanding of black hole mergers and neutron-star collisions. what it will eventually show us about objects like Behemoth. If it shows us anything, if Behemoth produces gravitational wave signatures of detectable strength, we cannot yet say. But the capability is coming. The instruments are being built, the communities are being trained, and at some point in the not-too-distant future, on the timescale of decades rather than centuries, the data will be rich enough, the instruments sensitive enough, the analytical tools sophisticated enough that the ambiguity around Behemoth will begin to resolve. We will know more, perhaps much more, perhaps enough to finally, clearly, confidently say what Behemoth is. And on that day, the question we have asked tonight, is it a star or something else, will have an answer. And the answer, whatever it turns out to be, will be extraordinary. Because the universe doesn't produce disappointing revelations. It produces revelations that are strange and beautiful and more complicated than you expected, and that open more questions than they close. The answer will be extraordinary. And then the questions will begin again. We are still learning how to see. And the universe is still full of things to see. That is perhaps the most perfect situation imaginable. That feels right. That feels like the appropriate response to something as magnificent as Behemoth, as the universe, as existence itself. Not certainty, not explanation. Wonder. Sustained, active, disciplined, honest wonder. Good night from all of us here at Infinite Science. The universe continues, and so do we.